Hello everyone, Paul here from Fixing Foundations. Today we are going to be talking about which numbers can be evenly divided by 3. So let's say we had 27 and we were wondering if 3 will evenly divide into 27. What we can do is we can take the two numbers here and we can add them together. So I'll use a different color for this. We can take 2 and we can add 7, and if we do this we get 9. And then we take a look at this number and we ask ourselves if 3 would evenly divide into this number, and it will. So if we divide 9 by 3 we will get 3, but this isn't as important. All we needed to know is if it will divide, and we know it will. And 27 divided by 3 equals 9, because 9 times 3 equals 27. Now going on to another example, let's say we had a larger number, let's say we had 39, and we wanted to divide this by 3, but we weren't sure if it would work or if we could evenly divide it. And in this case, even division means that we can divide 3 without getting a decimal or a remainder. So let's go to the side again. We'll take 3 and 9, so 3 plus 9 equals 12, and this can be evenly divided by 3. This can be divided by 3 to get 4. But let's look back over here. We can do 39 divided by 3, and if we write that over here, 3 and 39, 3 will go into 3 once. This is going to create a 0, and we drop the 9 down, and 3 will go into 9 3 times, and our final answer is 13. Now I want to show you something. Let's say we had 43 and we wanted to see if 3 would evenly divide into this. Well, let's take the numbers 4 and 3 and put them on the side here. If we were to do that, if we take 4 and we add 3, we are going to get 7, and 7 is a prime number. So 3 will not evenly divide into 43. And I'll show you another example of something that won't work. Let's say we had 163. We wanted to see if 3 could evenly divide into this. Well, we're going to take these 3 numbers now, and we are going to add them together. So we take 1, we add 6, and we add 3. This is going to give us 7 plus 3, which will give us 10, and 3 cannot evenly divide into 10. So neither is this number evenly divisible by 3. I want to just show you some larger numbers just to show why this principle can be useful. Let's say we had 414 and we wanted to divide it by 3. Well, we'll take these 3 digits here, 4, 1, and 4, and we will add them together. So 4 plus 1 plus 4. This is going to create 5 plus 4, and this is going to give you 9. And 9 actually can be evenly divided by 3. 9 divided by 3 equals 3. So we know that this will work. So now all that would be left is the long division. So we leave 3 here, we put 414 down, we start over here. 3 can go into 4 once, we subtract that, we get left with a 1, and we drop down this other 1. 3 can go into 11 3 times, and 3 times 3 equals 9. 11 minus 9 equals 2. And finally we drop down a 4. 3 can go into 24 8 times, and 3 times 8 equals 24, so This will just cancel out, and we are left with 138 as our final answer. I would like to do one more example. Let's say we had 543. So we had an even larger number, and we wanted to know if 3 would evenly divide into this number. We would put it through the same test. So we would take the digits 5, 4, and 3. We will add them together. This will give us 9 plus 3, which will give us 12, and 12 can be evenly divided by 3. So again, all we need to do is the long division. So we would take 3 and 543. We'll start by dividing 3 into 5. It will go into that once. 5 minus 3 equals 2. We drop down a 4. 3 will go into 24 8 times. 8 times 3 equals 24. So that will create 0, but we drop down the final 3. And 3 will go into 3 once. And this will give us our final answer of 181. Thank you very much for finishing this video. If you learned something from this video, please leave it a like. If you would like to see more tutorials related to mathematics, please consider subscribing to my YouTube channel. And if you're looking for online tutoring, check the description of this video. You may find something useful.